Okay, so today we're gonna finish up section 8. The notes today are 1.8b. Today we're gonna be solving rational inequalities. So now we're gonna have fractions in our inequalities. Now again, when you're typing in your answer, just like last night's homework, you're either typing in the word infinity or you're using that little equation editor, the math pad, to get the infinity symbol. And that's the same place you'll get the union symbol under the sets in that math pad. So these are the steps when we're solving rational inequalities. Again, what we need to do is get a 0 on either the left or the right side. Then we're going to combine the terms so that there's just one fraction. Now, when we solve these rational inequalities, we're keeping the denominator. We're not trying to get rid of it. Once we simplify it to one single fraction, we're going to set the numerator equal to 0 and the denominator equal to 0. That will give us our breaking points on our number line, and then we're going to solve it looking for the test points, just like we did with the quadratics. Do not solve these as a proportion. If you do, you're going to get them wrong. You must get a 0 on one side of the inequality symbol. Do not solve it as a proportion. You're going to see what I'm talking about. So for my first one, a lot of you may be tempted to just put a 1 under that 1, cross multiply, but you cannot do that. You have to get a 0 on one side of the inequality symbol. So what I need to do first is subtract 1 from both sides. And now I have 5 over x plus 4 minus 1 greater than or equal to 0. I need to find a common denominator. So I could show that this minus 1 is really 1 over 1. My LCD here is going to be x plus 4. So what this one is missing is the x plus 4. So whatever you multiply to the denominator, multiply to the numerator. We're not making the denominator disappear. We're leaving it everything. So now the new numerator on that other one. See, this is a negative 1, so I have to distribute that. So this becomes a negative x minus 4 over the x plus 4. I need to simplify this down to one fraction. So this now becomes, I can combine my like terms here, and then this becomes negative x, or 1 minus x, if you want to put it that way, x plus 4 greater than or equal to 0. Now I need to take the numerator, set it equal to 0. So x minus 1 equals 0. And then I'm going to set the denominator equal to 0. I'm just going to add the x, and I get x equals 1. Over here, subtract the 4, and x equals negative 4. So these are going to be the numbers on my number line. Put them least to greatest. And now we need to do a test point. So I'm going to go ahead and choose a 0. It's right here in the middle. So I'm going to plug in a 0 to the original. So my original was the 5 over x plus 4 greater than or equal to 1. Put the 0 for x. 5 over 4. 5 over 4 is 1 1/4. This is a true statement. So this gets the check. This gets the x's. So my final answer here in interval notation is going to be negative. Now, when it's a greater than or equal to, remember it was always brackets. However, remember the denominator, if it equals negative 4, it's undefined. So anytime you have this symbol, the bracket only will go around the numerator answer, okay? The denominator will never get a bracket, okay? Because if I plug in negative 4 into this, I get 0. So it can't include negative 4, but it can be all the other numbers. So when I go to write my interval notation, it's going to be a parenthesis around -4, but a bracket around the numerator answer. So just remember, whatever comes from the denominator always is going to get a parenthesis. The graph of this would look like, again with the numbers here, I'm putting a parenthesis around -4 and then the bracket and then joined in the middle. And that would be your graph. Always remember to put it least to greatest. So the denominator will, that answer from the denominator will never get a bracket. It'll always be a parenthesis. So let's try the next one. It's already set for me. So I'm going to go ahead and just set my numerator equal to 0 and my denominator -1, x equals -1, add the 4, x equals 4. Let me set up my number line. -1, +4. I'm going to plug in 0 to the original problem. So my original problem was x plus 1 over x minus 4 greater than 0. So I'm going to take out these x's, put zeros here, and then I get 1 over -4 greater than 0. This is a false statement. So in that middle section, it's an x, and then on either sides gets the check marks. So again, remember over here is the infinities, -infinity, +infinity. So my graph, because it started out as a greater than, is going to go from -1 to -infinity and +4 to infinity. So my interval notation, -infinity to -1, all parentheses, because it was a greater than symbol, and then 4 to infinity. For the next one, again, do not solve this as a proportion. Do not try to put a 1 under the 4 and cross multiply. We need to subtract the 4 from both sides. And I get 2x minus 1 over 3x plus 4 minus, and I could put a 4 over 1, is less than 0.
Thank you.
You're welcome. All right, so now what I need to do is find the common denominator. The common denominator is going to be 3x plus 4. So I'm going to go ahead and multiply this by 3x plus 4. The first fraction already has it. I need to distribute this -4 to the 3 and to the 4. So my first fraction is staying the same. My second fraction becomes -12x minus 16 over 3x plus 4. I now need to combine my like terms here in the numerator. So I'm going to combine 2x and -12x, and that gives me -10x, and then -1 and -16 is -17. I now need to set my numerator equal to 0 and my denominator. So -10x minus 17 equals 0, and the 3x plus 4 equals 0. Add the 17. -10x equals 17. Divide by -10, and x equals -17 over 10, which is either -1.7 or -1 and 7/10. Because we need to sort of have an idea of where to put it in the number line. Over here, -4, divide by 3, and x equals -4/3. This is -1 and 1/3, or -1.3 repeating. So it was important that I converted this when I go to put on my number line least to greatest. So here's my number line. The negative 1.7 is the smaller number, goes first, and then the negative 1.3. Again, I'm looking for a test point. Notice this time 0 is not in the middle. 0 is located over here. So I'm going to plug it in, and then the result of if it's true or false, that's where the section will get the check or the x. So my original problem, 2x minus 1 over 3x plus 4 less than 4. Put in a 0 in both of these spots. And this one, again, becomes negative 1/4 less than 4. This is true. So I get a check mark where the 0 was. The middle gets an x, and the end gets a check. So my graph is going to be, the original symbol was a less than. So parenthesis going this way, parenthesis going this way. Again, remember over here is negative infinity, positive infinity. So my interval notation will be from negative infinity up to the negative 17 over 10, or you could put the 1.7 union from, I would leave this as the negative 4/3 because this is 1.3 repeating, and you can't key that into WebAssign as a repeating, going to infinity. The next one has a less than or equal to, but remember, the only number that will get a bracket is the answer that comes from the numerator. The denominator's solution, or the breaking point, will never get a bracket. It'll always be a parenthesis. So let's go ahead and take a look at the next one. Again, do not solve it as a proportion. So what we need to do is subtract 2 from both sides. And now my fraction becomes 6 over 5 minus 3x minus, and I could put 2 over 1, less than or equal to 0. My LCD is the 5 minus 3x. So I'm going to multiply that to the numerator and the denominator here. And I'm going to distribute this 2 as a negative 2. So once I distribute, my first fraction stays the same. And then once I distribute, I get negative 10 plus 6x. Same denominator still. Less than or equal to 0. Combine your like terms in the numerator. So 6 plus negative 10 will give me negative 4. So 6x minus 4 over 5 minus 3x. Now set the numerator equal to 0 and the denominator. So 6x minus 4 equals 0. And then the denominator 5 minus 3x equals 0. Add the 4. 6x equals 4. Divide by 6. X equals 4 over 6, which simplifies to 2/3. Over here, I'm just going to add the 3x. 5 equals 3x. Divide by 3, and x equals 5/3. 5/3 is like 1 2/3. So that's the bigger fraction. I'm going to place this on my number line. So I put the 2/3 first, and then the 1 2/3, or the 5/3. Now again, I'm looking for my test point. 0 is located over here because both of them are positive. So once I plug it in, this is going to be the section where I put my first check or x, depending on what I get. So let me go ahead and plug it in. My original problem was 6 over 5 minus 3x less than or equal to 2. So where I see the 0, where I see the x, I'm putting a 0. So then this is gone, it becomes a 0. 6 over 5 less than or equal to 2. 6 over 5 is 1 1/5. That is less than 2, so this is true. So this section gets the check, the middle gets the x, and then the check. So again, we've got our negative infinity here, our positive here. Now remember, only the answer from the numerator, which was the 6x minus 4, this is the only answer or number that's going to get the bracket. The 5/3 is going to get a parenthesis, because if I plug in 5/3 to that denominator, it makes it undefined. So what I'm going to put here is going to be a bracket around the 2/3 going to negative infinity, but the 5/3 will be a parenthesis. So my final interval notation, negative infinity up to the 2/3 with a bracket, union with the 5/3 with a parenthesis to positive infinity. So the denominator answer, when it's a greater than or equal to or a less than or equal to, will never get a bracket, only the numerator. All right, so for the next one, again, don't solve it as a proportion. We need to subtract the 5 over x. I need to get a 0 on one side of my inequality. I now need to find a common denominator. My common denominator is going to be both of these. So the first fraction is missing the x. So I have to multiply the top and the bottom by x. The second fraction is missing the 3x plus 2. Whatever you multiply to the denominator, also do to the numerator. So my new numerator on the first one is just going to become negative 5x over the x times 3x plus 2. I'm going to again distribute this as a negative 5. So negative 15x minus 10 over the x times 3x plus 2. I now need to combine the like terms in my numerator. Don't FOIL the denominator, because remember, or distribute the denominator, because we're going to have to factor it anyways to solve. So just leave it like that. I'm going to add, and I get negative 20 x minus 10 over x times 3x plus 2. I now set my numerator equal to 0 and my denominator. So for my numerator, negative 20x minus 10 equals 0. I'm going to go ahead and add 10 to both sides. Negative 20x equals 10. Divide by negative 20, and x equals negative 1/2. Now remember, my original symbol was a greater than or equal to. So remember, when I go to graph this, this one gets a bracket. However, the denominator is going to get a parenthesis. And all I do is take each of the factors, set them equal to 0, because I didn't distribute it. Divide, and x equals negative 2/3. So I have x equals 0 and x equals negative 2/3. So now let me go ahead and put this on my number line. Now notice 0 is one of my answers, so I cannot use that as a test point. So negative 2/3, then the negative 1/2, then the 0. I'm going to go ahead and plug in 1 as my test point, and 1's located over here. So take your original, -5, plug in a 1 for x, -5 over 3 plus 2. 3 plus 2 is 5. -1 greater than or equal to 5. This is false. So the section that has the test point gets an X. Then this is a check, an X, a check. So now when I go to graph it, remember only the 1/2 got the bracket. So this is a bracket with a parenthesis on the 0. And then over here, parenthesis going to the -infinity. So my final answer here in interval notation, -infinity up to the -2/3, parentheses, union with bracket -1/2 to 0, parenthesis. Yes. Not solve this as a proportion. I need to move one of them to the other side. So let me move this one, because I need a 0 on one of the sides of my inequality. So 1 over x minus 3 minus, and if you want to think of this as a -3 here, 2x plus 1 less than or equal to 0. I need to find the common denominator. It's actually going to be both of these. So my first fraction is missing the 2x plus 1. So I'm going to multiply that to the numerator and the denominator. So distributing a 1 to that, it just stays the same. Over 2x plus 1, x minus 3. Then this one is missing the x minus 3. Distribute a -3. So this gives me -3x plus 9. And it's less than or equal to 0. I need to combine my like terms. So when I combine the 2x and the -3x, I get -x. And then the 1 and the 9 gives me 10. Leave the denominator factored. Do not FOIL it. Because now what we're going to do is set the numerator equal to 0 and the denominator. So if you FOIL it, you just got to factor it back. So do not FOIL the denominator. Okay, so now I set the numerator, -x plus 10. And again, remember, only the numerator answer is going to get a bracket. So -x plus 10, I'm just going to add the x, and 10 equals x. This is only going to be the answer that gets the bracket. And then set the denominators equal to 0. So 2x plus 1 equals 0. And x minus 3 equals 0. Subtract the 1. Divide by 2. X equals -1/2. Add the 3. X equals +3. So let me set up my number line. Put the numbers on the number line from least to greatest. So the -1/2 goes first, then the +3, then the +10. I need to pick a test point. I'm going to pick 0. So I'm going to plug it back into the original. So my original was 1 over x minus 3, so 0 minus 3, less than or equal to 3 over 2x, so plug in the 0, plus 1. This gives me -1/3. This gives me 3 over 1. So -1/3 is less than or equal to 3. This is true. So the section that has 0 gets the check mark. and then the pattern repeats. So again, the only thing that got the bracket is going to be the 10. So a bracket on the 10 going to infinity. And then this one over here, the -1/2 and the 3 get parentheses. So it's joined here and a bracket this way. So my interval notation is going to be from -1/2, comma 3, in parentheses, unioned with 10 to infinity. And the 10 is a bracket. So again, I'm going to move the 3, subtract it from both sides. So 2x minus 7 over x minus 5 minus 3 less than or equal to 0. So I could put a 1 here. And again, I'm going to do like a keep flip change, and I'm going to make this a plus and then make that a -3 there. My LCD is going to be the x minus 5. So this one needs it. Multiply it to the top and the bottom. So now I have 2x minus 7. This fraction stays the same. This one I have to distribute the -3, and I get -3x plus 15 over that LCD. Combine your like terms in the numerator. So 2x minus 3x gives me -x, and then -7 plus 15 is +8. I now need to set the numerator equal to 0. So -x plus 8 equals 0. And again, notice the only thing that's going to get the bracket is what's coming from the numerator. So here I'm just going to add the x. So x equals 8, and this answer will get a bracket. And then the denominator, x minus 5 equals 0. And I get +5, but this is going to get parentheses. So let's put this on your number line. Because again, it would make that denominator undefined. Put it on your number line from least to greatest. So +5 here, +8 here. Notice that 0 is located over here on the far left. So I'm going to plug it into the original. So 2 times 0 minus 7 over 0 minus 5 less than or equal to 3. This gives me -7 over -5. -7 divided by -5, this becomes +7 over 5. And +7 over 5, if I divide this or make it a mixed number, it's 1 2/5. This is still a true statement. 1 2/5 is less than or equal to 3. So this section gets the check. This gets the X and the check. So again, the only number that gets the bracket is the 8. So bracket here, going to infinity. And then this one is a parenthesis going to -infinity. So my interval notation, -8 to the 5 with a parenthesis, union with bracket 8, comma, infinity. And that is it for 1.8b. So when you're doing this on WebAssign, be very careful, watch your grouping symbols. Remember when to use the bracket and the parentheses. And again, you could use your equation editor for the infinity symbol and for the U.